a few times before. This is supposed to be a discussion session, and we can go through papers, we can go through things we're reading, we can have presentations like we've been having before. But what I wanted to do today was to go through a little bit of a thought process on at least how I engage on conducting analysis whenever they come to me. And we've covered this a few times over our Gemini sessions, but not everybody's there, and I think it's always good to have uh, a reminder here or there. But also, I just want to go through a little bit of the thought process, because I feel like several times when we're engaging on discussing papers and results, we end up going back and forth because we haven't really thought through the process, and have steps in the middle that we have to take care of. So let me see if I can share my screen. Let's see. Cool. Okay. And this should work. All right. And as I said, I don't have anything prepared, so I will encourage you to ask questions or engage. Otherwise, I might go too quickly or not. We'll see. I like to talk a lot. So, uh, so the thing I want to talk about is how I approach thinking about doing analysis. And I'm going to talk about it in two ways. First is revisit the process, because again, I feel like we lose a lot of time redoing things several times, and that's never good. And then thinking about the decision process, which are two things. So let's talk about process first. When I'm thinking about process for doing the analysis, we always have to start with a question. And the question usually gives you all the directions to what you need to do or what you need to think about for your analysis plan. Sometimes there's some nuance to it, but the question should always guide your decision. The main error I see trainees do when they are trying to build their analysis plan or conduct their analysis is not follow the question. And in particular, don't specify in the question a direction. So what is the outcome? What are the predictors? And if you don't do that, and you start to just look at the data and see try to get a narrative from the data to then try to find the question, you're going to lose yourself on all the potential things you could do or could have done. So that's never a good idea. The good idea is always to start from the question that should be necessarily linked to some sort of theory behind the question. So in deciding the question from this process here, only by looking at the question, you're going to have some guidance on what is the outcome, what are the predictors, any potential confounders, or strata, or any grouping, and you're going to have a direction on what kind of methodology to follow. Just on the question. So that's a few years ago, before we started thinking about this from a statistical analysis plan perspective, what my research group used to do was to think about the question in something that was called a question diagram. Oops. That maybe we could start using again as a step towards building the analysis plan. But the idea of the question diagram was very simple. You would come into a Word document where you would specify the hypothesis, the conceptual hypothesis, not necessarily the statistical hypothesis, but the conceptual hypothesis. You would specify from the hypothesis what is the outcome, what is the predictor, what are the confounders, and then you would come with a definition of the variables or the data that you have to further specify this indicators. And then you would come with mock tables or examples of tables that you want to build. Everybody here that has engaged with me in an analysis so far have seen me ask you for this, ask you for a table of variables, ask you for mock tables or mock graphs, because that allows me, or what I'm trying to teach you, allows you as the analyst to understand how the researcher, the content expert, is thinking about the data. And that gives you some indication on how you could suggest better approaches or different things. So from the question, this would be the first document we would start to generate a question diagram, which in recent years, I kind of translated this into the SAP. So the statistical analysis plan. For those that have been coming to this call, I think Nathan or João Vitor have presented on a template for the statistical analysis plan. The video should be available, or if you want to see the video, you can just also just ask. But there's a template on the statistical analysis plan, which is a little bit more detailed than the question diagram, but it still has the same concepts in it. You have a little bit of the idea behind the question, and then you specify what are the variables, what are the hypotheses, what are the data sources, and then you should have mock tables and mock graphs. A mock table and a mock graph, what I mean by mock, and I'm going to mention that because it took me a few years to ask my mentor what a mock was because I was embarrassed. But a mock means that it's a fake, it's for show. So you can create a shell, you can create a structure for it, an empty table, or you can find papers that did similar things to what you're thinking about doing and copy those and paste it on the plan so that we can then discuss. So that is the first thing. If you can't, and this is important, so if you're writing an email, stop and listen to me now, and then you can go back. If you can't find the outcome and the predictors and have a direction on the methodology just by looking at the question, then the question is not good enough and it needs to be rethought. Is that right, Ashley?
What?
You have to think about it again. You have to redo it.
Rethink?
Yeah. How do you say rethink in the past tense? It needs to be
rethought.
Rethought. Is that correct?
I guess.
Yeah, it's a very Portuguese passive sentence. Yeah, so it should be, the question should give you this direction, okay? And then there's different words you can use in the question that are going to give you this direction on the methodology. So once you start looking into that, a few of these words that kind of point you towards this. Let me go back to a different color. Colors here. Come on. Like a light blue. Light blue. Okay, go back to black. So a few words that can give you some hints on it. The first thing that I like to see when I'm looking at this is this going to be a multi, and this is the catch, Is this going to be a multivariate approach or a multivariable approach? Then the next thing I'd like to see is this going to be a predictive question or is it going to be an exploratory question? And then if it's exploratory, then I can break this down into further. Is it going to be a confirmatory question or really an exploratory model? Exploratory model. Then the next thing you can also see is what is the confounding effect and how you're going to measure that, how you're going to address that. And by addressing that, I mean, do you have a good DAG to build your model from? Or do you have to address dimensionality problems? So all of this information you should be able to get just from the question or just from engaging on the question with your content expert or your whoever the question is. So great. Now you have a question. Question is driven by theory. You define this question well enough that you can identify roles. And these roles start to point you towards some methodological approaches. So then the next part, oops. So then the next part is some thoughts about the feasibility of the question, which most times it goes, most times the domain experts or people that are thinking about the question are not very aware that the question they are trying to answer is not possible with the data they have available. So the first thing that you have to do is look at the data. I can't make enough arguments to why you should always look at the data. Look at the data first. And when I say look at the data, the first thing I'm going to look at the dictionary. And this is not a data management discussion, so I'm assuming you're all going to have a very beautiful, very thorough, well-described data dictionary coming to with your proposed question. But look at the dictionary and look at the variable definitions. I'll give you an example of something that I'm working on right now. So one of our students from Gemini, Gianni, is having her first draft of her thesis, which is great. But in the process of developing her thesis, which Nathan helped us with the analysis, she wanted to look at hospital readmissions. And a readmission, by definition, is a second admission to a hospital that happens within 30 days of a first admission, for which the cause of the second admission is linked to the first admission. So you're getting admitted to the hospital again within 30 days for something that is related to the reason you went to the hospital for the first time. So she wanted to study that, and we were going back and forth on how she tried to fill study options. She found a few data options, and none of that worked until we find one data source that is called the Brazilian National Health Survey. And then for a long time, we believed we were going to be able to do the readmission studies until we sat down and started looking at the data, and we noticed that we couldn't really do readmission study with that data set because there was no way to link the admissions to the first reason they got admitted to the hospital. We could only look at number of hospital admissions within 12 months. Sorry, my headphones lost battery. Hang on. Okay. Can you hear me now? Is that working? Okay, good.
Yep.
Okay, so that means that her initial idea of looking at readmissions was not possible because the variables available in the data dictionary wouldn't allow her to study that. What they would allow her to study was number of admissions in the past 12 months, which is a different question. So her question was not feasible. And if you're not looking at that from the beginning and you end up looking at that, which was her case, at the analysis phase, then you lost all the months you spent reviewing the literature and preparing the documentation because you didn't look at that from a feasibility perspective. Okay? So the first thing you do is look at the definitions and look if the data you need is available in the data set. Okay? Great. The next piece, and I have several examples to give at the importance of looking at the dictionary. The second piece is look at the data distribution. And this is probably the most important part of any analysis approach. Because if you don't understand the distribution of all the data points you're going to analyze, then you have no idea how you're going to interpret the model results. And that attests to the feasibility as well. So I know of some colleagues from the track program that have been suggesting thesis work until they started looking at the actual data and noticed that the data they wanted to evaluate had very small variance, if any at all, or had very small frequency of cases, if any at all. So if you have very small frequency of cases, you probably can't do that study. And the study, the proposed study then, it's not feasible or a problem with the data. So you always want to look at the data distribution. You always want to have in the start of your study at least a histogram for numeric data. And we don't have to go through this here, but that's going to give you a bunch of information on data distribution, skewness, kurtosis, variance, and a bunch of important things that help you think about how to use that data. You want to look at frequency distribution for categorical data. And you definitely want to look at missingness. And missingness, as Timoth knows very well, is probably the area where most people get things wrong or get stuck on and spend months trying to figure out how to handle. Long story short, there's never a good answer. And you always have to make some compromises on how you handle it, but you have to handle it. Or at least you have to tell whoever your analysis plan is or who you're working with how you handled it. What you cannot do, and I've been on meetings with folks on this call discussing this, is you cannot come to a discussion about your results and don't have a good answer on how you handled missing. Okay? Good. It must be handled before the analysis is happening. And then again, spoiler alert, the answer cannot be R handled it on the analysis process. The answer cannot be I don't know how I handled it, because when I linked data sets on ArcGIS handled it. Because that probably means you're excluding data without being aware that they are being excluded. So if you've done at least this, ideally, I would like to see 2x2 tables or some correlation plots. Between at least the predictors and the outcomes, so you have some idea of how those are distributed. In particular, these are going to help you deal, for instance, with when you have less than 5% cases on the contingency table problem, things that are very important when you're planning your analysis. But at least you should have a univariable histogram or frequency distribution to understand your data. Because when you run your logistic regression models and you start to see odds ratios of 100, that is probably due to a low frequency than really the fact that there is 100 times higher likelihood of an outcome for a given group. So far, so good? Okay, awesome. This should all be on part 1 of your analysis as you're developing your statistical analysis plan, because these things have an iterative relationship with the SAP, because they are talking about the feasibility. Once you've looked at this and you went back and forth a little bit, then you can close your statistical analysis plan when you get to the third piece. In the golden ages, when I was really hands-on doing analysis and I didn't have to rely on trainees to do analysis for me, I would have a piece of code in R, which is kind of like trying to, that's not a good analogy. I had a piece of code in R which would iterate through the data set, and for every variable in the data set that I was analyzing, it would create a univariate graph, and it would create a 2x2, so a bivariate graph between each of the variables in the data frame, which would create reports of 100 pages. Of course, automatically, before tidyverse existed, so it kind of like in the rock ages of data science. There was a bunch of codes to do that, but that's what we would go through to be able to have this comprehension on the analysis plan. And ideally, that's what I would love to see from everybody. Now you can make shiny apps, which is a lot easier than having 100 pages. You can plug and play and have a drop-down menu to see which variables you want to look at the description. But that's what I would love to see when we go into the statistical analysis plan meetings to discuss the study. So cool. And I see, because I see Monique here, this also works for these meta studies, like psychometric studies, because you also want to see the descriptives of the observations when you're trying to do a psychometric evaluation. Right? There's several times where there's problems with your factor analysis models because one of the options in your scale does not have endorsement in all of the Likert options. And therefore, the code won't run and you're going to have problems. So it's important to know that as well. Okay, questions so far? No? All right.
I have a question. It's probably explain the treatment for data or the missing data and the three forms, eliminate, selection, and imputation data, because it's very important. If you will, it's not determinate what the percent is probably for imputation of data.
Yeah.
If necessary, explain this, because it's most important for the rest for the analysis data. For example,
Yeah.
so algunos investigadores, the elections for the missing data and the late. Other depends for the context for the hypothesis. Other apply always imputation, but the 3/4 for imputation data, independence for data. What is the process best for you and the imputation data or treatment for the missing data?
Yep. Talk a little bit about that. I'm just making notes of the things you said. So yeah, I mentioned about that. I think we should probably have some sessions just talking about different ways to do to handle missing data. But so ideally, let me make this up. So ideally, for everybody that is aware, missing data is whenever you have a table like this one that I just created, where you have the observations here. So this is patient number 1, patient number 2, patient number 3. And then for any of the variables, you end up having a missing, which is a blank case, right? A missing can be information that is missing, or it can be information that was chosen not to be reported. And those two distinctions are very important, because if it's chosen not to be reported, then it might mean that there's some bias on that data. And it's not just missing because somebody forgot to reply. Because there's a problem on bias on how data is missing, you have to address that somehow. The way that people mainly address this is by using what's called a complete case analysis. Complete case analysis. And a complete case analysis is a case where every participant that has missing is excluded from the study. And I'm only analyzing complete cases. The problem with doing complete case analysis, as it's a problem with any kind of missing data handling, is that if the missingness is not random, then your analysis is going to reproduce whatever bias the data has. So for example, if I am collecting data and I'm doing a survey, and then most participants in my survey from low-income areas of town refuse to answer the question about whatever social determinants of health, and I remove all of them, then any coefficient of the association between two variables that I identify is going to be biased, because those that are most impacted by social determinants of health are out of my study because they didn't want to answer the question. That's a very common problem, for instance, when you're studying interpersonal violence and you go to do a household survey and you're trying to look at domestic violence, and then you're trying to ask about domestic violence in the house, where you're asking a person that is receiving violence from her significant other, and they are in the same room. You're probably going to have missingness or biased responses. So a complete case analysis is usually good when you can show that missingness is random, meaning that whatever case you have missing in your data is missing due to randomness. There's no pattern to explain it. There's a few ways to address that, or there's a few ways to evaluate that. That's not the point of this conversation. And we can go through that in a different discussion. I'll call you in a minute, Ashley. But even if the missingness is not at random, and you understand the patterns of missingness, then you can still do a complete case analysis and then bring the limitations about this missingness. That's the example of the statistical analysis plan Nathan and João Vitor are developing for the elderly trauma project, where we looked at all the missingness patterns and we noticed that there's some particular cases we're just going to have to drop them because there's a lot of missingness in very important variables like what is your HIV status or what is your diabetes status. And there's a lot of missingness there. And the missingness in a question about do you have diabetes or not, were you diagnosed with diabetes or not, missingness, we are not sure if a missing data means no diabetes, not diagnosed, never tested, or not answered. So because we don't know, we're going to have to assume that that information is missing. And because it's missing for the majority of the data, we're probably going to have to drop the variable because we don't have good information on the variable. If it's missing for a small amount of people, and we can show that these people have similar social determinants or social demographics than the rest of the data, then we could drop that and in the discussion say, we've missed a lot of patients that didn't have their diabetes profile. One limitation is that maybe diabetes was very frequent in that population, and therefore we need to probably study diabetes a little better in a better described or better collected data or something like that. So you still did the same analysis, but you described the limitations based on what kind of missingness you had to exclude. The other way to address this problem, from what Silvana was asking, is to use some sort of imputation approach.
With sensibility analysis include in imputation.
Yes. So an imputation approach is an approach where you're trying to guess what number is supposed to be in that case. And there's a few ways you can try to guess. One way you can try to guess, and some people do, is by imputing the mean value or the median value. This works very well for psychometrics, for instance, because if I'm asking you 10 questions and I have one missing in one question, I can put the mean value there and I'm not going to change the evaluation. I'm not going to change the scoring for that particular question. But it's not ideal. It's not the best way. Though the best way to do imputation would be approaches that try to do some sort of probabilistic imputation, or where you're trying to predict what that case would be based on a set of predictors. And then there's a myriad of imputation techniques. There is regression-based imputation, a chained equation-based imputation, and there's different approaches to do that. But basically, you're trying to build a model that can predict what that missing value is, so then you can guess what that value is. But in every time when you're trying to do predictions, there's always an error to the prediction. So what we do when we approach with imputation techniques is what Silvana is mentioning, that is called a sensitivity analysis. Sensitivity analysis is used for several things in data analysis. It's usually used when you're trying to show how much is a model impacted by certain variations. In this case, if I'm trying to predict what is the value that is going to fill in the missing cases in my data, every time I do a new prediction, that value could change based on just some randomness in the prediction process. And therefore, what you do is you predict several times and you create several different new predicted databases, completed databases, and you run the analysis in all of them, and you show how that analysis is impacted by different imputation times or approaches. And that gives you an idea of the uncertainty of that approach you just used. It's also something that what I like to do in the studies where we are reporting missingness is that we conduct the complete case analysis, then we conduct the imputed analysis, and then we show the imputation, or through sensitivity, we show how the missingness is impacting the overall estimates, because there's always some errors in the imputation process. Go ahead, Ashley.
Yeah, thanks. So two things. I just wanted to, one, highlight what Joao was saying about the missingness being random and not random. So if anybody has any doubts about that, please ask, like, because it's important to understand, like, that the reasons that it would not be random are sometimes not obvious to us, or maybe we don't even know them. But that's really important. But second, a reason that missing data would not be random, or apparently missing data, and I didn't hear you say this, so I want to make sure we're clear on this too. I'm sorry if you did mention it, is when data appears to be missing, but it should be missing. In other words, a lot of times with our data that comes from REDCap, the data will seem like there's a bunch of missing for certain variables, but that's actually because of the branching logic. So that's when you have to go back to the previous step that Joao mentioned, go back to the data dictionary or the tool which was used to originally collect the data, and ask yourself, was this data supposed to be missing? So for example, Joao Vitor and I were just looking at some data where it explains if the person in a car crash was the passenger or the driver. That data is going to be missing for 40% of the cases because you had to have a car crash to be in that next question. Okay, so be really mindful when you see large numbers of missing. Sometimes you need to go back and look at the logic and ask yourself if it's supposed to be missing or if it's truly missing when we should have the data.
Thanks, Ashley. Great point. Branching logic is a problem we face many times with audit, which is a big variable we use on this group. And several times people come with saying, oh, there's 80% missing on this question, and it's not 80% missing. You just have to reshape that variable. Yeah. But again, this is not a discussion around data management strategies. It's a discussion about thought process on analyzing data. So yes, thanks, Ashley. João.
Sure. So I would like to also add to this notion of either imputation of or thinking about it, if you're thinking about a prediction task. So if you are working on a machine learning model and you have missing data, the first thing you need to consider is that there is this notion of data leakage. So when you're building your model, let's say you're using data from KCMC to build a model, and ideally you want this model to predict if this patient is going to die. So you're going to get this risk of this patient going to die. But this model is going to be used with data that you don't have currently. So it's going to be deployed for patients in the future. 1 year from now, this model is going to be used on these patients. So you need to try to mimic this sense, this notion of future patients that you don't have when you are building your model. So that's why you need to split your data into training and testing and all of that. But then when you look at imputation, depending on the way you do the imputation, you're going to use variables that would not be available at the time that you are deploying a model, or even using information from this test set, which should behave as the like future set of patients that would not be available at the time. So it's an additional concern that you need to have when you're working on missing data in these scenarios or in these situations. So what you would need to do is consider missing data in the two sets as they are independent between themselves and do the imputation separately. That's an approach. And the final thought also in that scenario, from my experience doing some modeling with that approach from some of the projects I've seen, is that even if you generate like 20, 30, 100 versions of your data set by doing this, as Charles said about the multiple versions of the data, the prediction doesn't change very much from the experience I had working with some of these data, but it's very important to represent or to show this confidence interval or this notion of error when you are doing the imputation. That's it. Thank you.
Thank you, João. And I want to address it a little bit because William made a comment here, and I've had this conversation with them in Tanzania as well. So there's this discussion around should I impute the outcome or not, where some people have very strong feelings about it. My suggestion to you all is there's never a strong feeling about anything in data analysis. There are some rules to follow, but overall, it's always around trying to make the model that makes the most sense for the question at hand. And so I don't want us to come out of this with a rule saying you should never impute for the outcome, because that's not necessarily true all the time. For instance, take João's example. You're trying to build a machine learning model, and you're trying to build a model that can predict X outcome. And then when you split train and test, you end up losing a lot of your cases if you remove variables based on some sort of missingness, or even if you look at the outcome, you miss an important number of patients from a particular group because you don't have their outcomes. And you try some imputation approaches, and in the end, you're able to come up with a data or a model that functions very well in a non-imputed, clean, independent set of data. And if that's the case, I would argue, what is the problem? Why is that not a good approach? If it's accurately predicting real cases, then the coefficients you created to your machine learning algorithm that came from a set of models where you created different versions of imputed data sets, and that's working well, what is the problem? I fail to see a problem in that setting, right? But ideally, as an overall approach, we try not to impute the outcome because you are kind of generating new results and you don't want to predict things you just created, but that's not true all the time. And that's not true all the time, especially for us here that are trying to build models to solve problems in areas where data is not really available in abundance. And we have to make the most out of the data that we have. Okay, so I invite you to think about these things. I invite you to work with these things and try to find solutions. That's very different than trying to impute, for instance, an outcome that is very macro level. It's kind of like an ecological outcome. So you don't want to impute number of deaths in a state, for instance, if you don't have good metrics for it. The other thing I want to mention, which Silvana alluded to, is what is the rule of thumb around how many data points you should have missing to impute? And then I see Silvana mentioned here 10% of
Yeah.
missing.
Yeah.
Or here you also said survey, you have to meet at least 30%. So again, as I said, there's never a specific law to follow. There are some rules that guide you through. But if you look at some studies, there are studies that done simulation that showed for depending on what the variable is and how good your predictors are, you can create very good imputation models. And depending on the role of that particular variable in confounding the effect, you could impute that variable up to 70% missingness.
Joao,
Let's
and
say, yes, Silvana, please.
and in depends for the analysis. For example, in epidemiology, all the analysis is the 10%, but the data analysis or ciencia de datos is probably you have so many years for data. For example, 10 years, 20 years is probably applied deep learning for reconstruction for the serie for data. It's probably because I remember in this project applied this process for the construction for the quality air in Medellin. For the missing data is 34%. It's very difficult, but I found the method they apply this data with a sensibility data analysis for the limb for reconstruction for serie tiempo of data for quality collusion and the contaminante criterio. I don't say contaminante criterio PM2.5. It's probably, but independent of the type analysis. For example, an epidemiology is one and the data analysis is other. It's very important that this concept too.
Yes, I agree with Silvana 100%. What I invite you all, like Silvana is saying, is to think critically about the analysis approach and then think about the limitations of using one approach versus another. Think about which data point you're trying to impute and how, and that's going to give you a direction of how much imputing you can accept or not. And then in the end, always sustain your decisions with very good sensitivity analysis. Because what you're trying to do when you're imputing data, what you're trying to do is you're trying to retain most of the information that is valuable from the data source that exists. You're not trying to create new data, but you're trying to keep the number of observations. You're trying to keep your power, and you're trying to hold true the actual observation that exists. And so your sensitivity models will tell you how far off your assumptions are, and that's going to give you good direction of how much you can trust the effects or the coefficients you're developing on your analysis. Okay, so I would focus on that. The problem with focusing on that is that it creates more process. Therefore, if you spend time understanding your data before you start creating models and tables and outputs, it saves you time and it saves quality on the analysis process. Okay? So I was going to get to number 3, but we're out of time. So I'll get to number 3 next time where we have a slot, and I'll basically think just go through some key connections between different methodological families that allows us to think about which approaches to use. And we can do that next time. Can we pull up the spreadsheet and see how we're doing on presentations?
Yep. Let me get to that. Okay, sharing my screen now. Which screen are you guys seeing? Our studio or Gemini spreadsheet?
Scripts sheet, yeah, the right one.
Okay, cool.
Yeah, that works. Okay, so for next week, we have Rosalia. Rosalia, do you have a topic you wanted to talk about?
Yes, I'll ask Joe to send me the link so I can update it there in the
Okay.
document. Yeah.
Sounds good. Can you paste the link on chat room, please?
Yes.
All right, thank you, Rosalia, for sharing that. And then we have Lais presenting on eSAM modeling, great. And we have Nathan doing some hands-on data linkage, that's very good. All right, and then we have Igor on cluster analysis. Cool. All right.
I have some materials that I had for a previous presentation on the other on the data analysis call as well on missing data.
Yeah.
Is it something that we want to bring back?
I think it would be good to show a workflow on missing data. I think there's two sessions want to be made. One is a more like an introductory, like what's the framework for missing data handling that we use. I think I would like to work with you on that.
Mm-hmm.
And then have a templated codes of how we want to address that. I think that would be a good idea. We can get those from the recent analysis we're doing.
Mm-hmm.
Yeah.
I also have maybe it's something that we could also show in the like analysis framework.
Cool.
The framework for exploratory data analysis.
Yeah.
I have a draft for a shiny application that is gonna automate this report and show it nice.
Beautiful, beautiful, beautiful. All right, and so now I would like to see who wants to volunteer to work with me on a set of templates for generalized linear models. So who wants to volunteer to work on templates in R to do linear regression, to do binomial regression, to do Poisson-based regression, and to do survival analysis?
Well, I would like to.
Okay, I love the enthusiasm. So let's do one at a time, please.
Yes, because I'd like to learn more about this. So I think it will be a good opportunity.
Okay, you can take
I know
all, and you
this.
can take just one. That's fine.
Okay, I don't know. I know the theory, but I don't know how to do.
Okay, sounds good. Who else wanted to work on this? Did somebody else?
Joao is probably explain the components principle of analysis because it's very important for detection for the next model. For example, you apply the script analysis, but don't think what is the best model. For example, for me, and always apply the components principles because in the signals for the what the model is very good for this data. And I always include for this analysis for the script, but is only signals and the components principles, and is very good explained for the other teams because it's important apply for other analysis.
Sounds good. Sounds good. Yeah. That brings me back to I wanted to start a small series on I think it's two things. One is psychometrics, and the other one is dimensionality reduction, which I think kind of talk to each other. So we're running out of time, but I have a few more minutes. Do you have a few more minutes, João, or do you have to go somewhere else? Okay, so let's list out topics here, and then we'll see who wants to. And for all the topics we're listing, I'll compromise with you guys to share a paper or maybe share a set of codes to work on a template, and then we can work together on it in parallel. Yeah, so let's put there, João. Yeah, linear regression. Let's not call it logistic regression. Let's call it binomial based regression, and then we just talk about the different families.
Okay.
Yeah.
I'm just taking names for folks that are saying chat. Kiana says she can take one as well. Kiana, do you have any preference?
So let's give Lais one, because Lais was the first one to mention.
Lais was the first, yeah.
Yeah. So let's see. You okay doing maybe you can do Poisson models, Lais?
Okay.
And then
Nice.
and then Kiana can take survival. The good news for all of you is that I already have very good templates for this. I just want to work on them a little bit and clean them up a little bit.
Yeah,
Joao is probably explain the GAM, the generalized adaptive model, for example, for series de tiempo is very important too.
Yeah.
For example, the
good.
mortality data is sickness line, pues estudio de enfermedades de largo plazo.
Yeah, that's a good one too. Okay. So João, add a few more lines there.
Mm-hmm.
So then let's do a series of, and these don't have to be in sequence, okay? You guys can take whichever date you feel like it. So let's do a sequence on psychometrics.
Okay.
And we'll start with, so you can say psychometrics 1, and let's do intro to content analysis. No, on the same line. So the same way you did GLM, let's do psychometrics 1, and then intro to content analysis. Yes. And then psychometrics 2, let's do factor analysis and principal component. Let's put them together. Psychometrics 3, let's bring some item response theory. Psychometrics 4, let's bring some network concept.
That's nice.
And then psychometrics 5, let's talk about reliability measures. And that's the bulk of it.
Yeah.
We can bring more concept, but that would be the basis. And then you can have another one which is like psychometrics for the paper template on
Mm,
skill development.
wait, is it like the 6th one?
6, yes. Yes.
Okay. Am I writing this correctly? Sorry, I'm
Yeah.
butchering it.
Yes.
Psychometric 6 template for paper.
Template for writing. So the paper template.
Paper template. Okay.
Yeah.
Nice.
Cool. Let's do that. And then let's have a line there for GAN models. But I need to study that a little bit more.
GAN,
Yeah.
like this? GAN.
Uh-huh.
Models. Okay. Sounds good.
Okay, so please, Laiz, Edwin, Rosalia, Kiana, just pick a date and put it there. And I'll share the templates with you guys, so you should be able to work on them. And then whoever wants to take some of these psychometric topics, I see Silvana already listed her up. That's great. Awesome.
Awesome.
Cool.
Great.
Cool. All right, sounds good. Thanks, everyone. See you all next week. Bye.
Thank you.
Thank you
Bye.
all. Bye-bye.